So in this video I want to talk to you about polyatomic ions. The reason I want to talk to you about polyatomic ions is they are very common. This is not an arbitrary list. Compounds like carbonate, sulfate, nitrate, iodate, bromate, they occur a lot. What polyatomic ions represent are a common clustering of atoms to make molecules. So when we have the periodic table, we have elements, and things come together to make elements. And an aluminum atom is an aluminum atom, a boron atom is a boron atom. Polyatomic ions can act like big atoms, statistically when we're not changing oxidation stage or doing specific reactions to those polyatomic ions. So if we have carbonate, it'll act like a big -2 atom. If we have nitrate, it's going to act like a big -1 atom, and we can treat them like that. They also have properties specific to them, such as solubility. Certain carbonate compounds are soluble in water, certain ones aren't, whereas all nitrate compounds are soluble in water. So this is why we make you memorize the list of polyatomic ions, is that they are used quite a bit, and they are used basically like atoms when it comes to naming compounds, deriving chemical formulas, and they have very specific properties that we will use throughout the semester to dictate solubility and acidity and things like that. So this video is not here to tell you what the polyatomic ions are. Those can be found on the course website. This video here is to kind of give you a little bit of help with memorizing them, because there is a trend in the naming, and there's a trend in the naming that you can use that you don't have to memorize all of them. Just memorize one or two and then use the naming to derive the rest of them. Now, is there a rule when it comes to polyatomic ions about how they're named? Well, yes and no. There are trends. A ATE ending does not mean 4 oxygen atoms. So if we have nitrate, which is NO3-1 versus sulfate, which is SO4-2, you can see that that name doesn't really correspond to the number of oxygens. But there is a trend with the polyatomic ions, and you can use this trend to help you memorize one and derive the rest. First trend is that if we have an IT ending versus an ATE ending, the atom that ends in ATE has one more oxygen than the one that ends in ITE. So sulfate versus sulfite. Sulfite is SO3-2, sulfate is SO4-2. Nitrite is NO2-1 and nitrate is NO3-1, so they differ by an oxygen. Are there other trends? If we add the hypo to an ITE, we're going to lose 1 oxygen relative to the ITE. So if we look at hypochlorite versus chlorite, hypochlorite is ClO-1, chlorite is ClO2-1. So whenever you add the hypo, that's subtracting 1 off the ITE. If we add a per to this ATE, we're going to add 1 more oxygen. So if we look at bromate, BrO3-1 versus perbromate, PrO4-1, that per is going to give us 1 additional oxygen. Now this gets kind of easy when you look at the chlorate series. So we have the ClOs, and the ClOs are a series of 4 polyatomic ions, all containing a -1 charge, but they each have a different number of oxygens. You only need to memorize one, and that is hypochlorite. So hypochlorite is ClO-1. To go from hypo to ITE, we add an oxygen. So chlorite is ClO2-1. If we want to go from ITE to ATE, chlorate is ClO3-1. And from chlorate to perchlorate is just ClO4-1. And this is true of the iodate and the bromate series. We have hypoiodite, which is IO-1. To get rid of that hypo and just go to iodite, we just add an oxygen. So to go from IO to IO2. To go from iodite to iodate, we add 1 more oxygen. And to go from iodate to periodate, we add 1 more oxygen. These endings don't change the charges. So to go from an ITE to an ATE, it's still going to be the exact same charge as before, but now you're just changing the number of oxygens. And we'll go through when we start doing Lewis theory. This is Chem 1 or Chem 2, we probably won't cover it. But again, we'll try to explain why this can happen in terms of not changing the charges. But these are your general trends here. If you want a quick and dirty way to memorize a lot of them, just remember the difference between ITE and ATE is 1, and you've only got to memorize 1. You can derive the rest from there.